Okay, welcome back. So we are now starting with the another distribution, that is normal distribution, log normal distribution and standard distribution. Again, let us see the steps that how actually we are working. We have one data. Okay, suppose the data are of the returns of S&P 500, means we are taking the daily return of S&P 500. So someday you will find 3%, someday you will find negative 2%, someday you will find 1.5%, someday you will find minus 0.5%, someday you will find say 2%, someday you will find 1.5%, someday you will find minus 3%. So this can be the daily return of S&P 500. Now from this daily returns of S&P 500, you got to know that these data follows normal distribution, that this data follows normal distribution. Okay, I will tell you what is normal distribution, but this data follows normal distribution. Also, we have calculated the mean of this data, as well as we have calculated the standard deviation of this data. First thing which we identified from the data, that data belongs to normal distribution. Second thing we identified from the data is the mean of the data, we can easily find out. And third thing we got to know is the standard deviation of the data. Clear? Now first of all, we'll start and understand what is normal distribution. What is normal distribution? Means how can I say that my data belongs to normal distribution? There must be some properties of normal distribution. So let us see. First of all, if you look at the data will look like this. Data will look like this, where you will find out the maximum amount of data, where you will find out the maximum amount of data around the mean, and probability in the tails, is very low. Probability in the tails is very low. So first point, write down, maximum amount of data lies around the mean, or in a better way you can present it like this. This is your mean, clear? Now one standard deviation away from the mean this side and one standard deviation away from the mean this side will consider 68% of the data, means if my mean is 3%, and suppose standard deviation is say 1.2%, standard deviation is 1.2%. so this part will be 4.2% and this part will be 1.8%. So means between the range you can write down between 1.8% to 4.2%, you will find out 68% of the data. Okay, 68% of this data. This is the data. Okay, this data can be of say 1000 days, so out of 1000 days, 680 data will be the part of 1.8 to 4.2%. Clear? Now if I'll increase more, let us move to 2 standard deviation away from the mean. That is 3 plus 1.2 multiply with 2, that is 5.4, and here it will be 0.6. Clear? So now you can write down between 0.6% to 5.4% will include 95% of the data. Suppose there are 1000 data we have. Okay, so 680 days data, and here 950 data belongs to this part. Clear? Hopefully you are understanding the theme. Clear? And If you'll go 3 standard deviation, it will include 99% of your data. Means around the mean, if you'll go 3 standard deviation, see what is the meaning of standard deviation? It says you that how much you can deviate from the mean, It can be 1 standard deviation, it can be 2 standard deviation, or it can be 3 standard deviation, but it's about the deviation from the mean. Clear? So we got to understand one of the basic property about the normal distribution. Second, this one is symmetric. Okay, now when I'm saying symmetric, what is the meaning? The meaning is that if this is your mean, then towards the left it will include 50% of the data, and towards the right it will include the 50% of the data. Means it is symmetrical in nature. Clear? Third point, if it is a normal distribution, then your mean is equals to median is equals to mode. Mean, median and mode, they all are going to remain the same. Clear? Now next point is skewness is equals to 0. If your skewness is coming equals to 0, means what? This is your normal distribution. Also, if you are calculating kurtosis, that will be equal to 3. Clear? So if you got to know all these things, are present in your data, now you can tell that your data belongs to normal distribution. If all these properties belong to the data, you can say with confidence, okay, my data belongs to normal distribution. Okay, so now we got the normal distribution. Clear? Again, let us see the steps. This is my data. From the data, first of all, we will identify the data. We will identify the distribution, that which distribution my data actually belongs to. Then I will calculate the mean of the data. I will calculate the standard deviation of the data. Clear? This is the point which must be clear in your mind. Now there is a question, why there is a need to identify the distribution? Write down why we need to identify the distribution. Means why we actually want to know the distribution? Because we want to know the, write down, because we want to know the probability, for the given value of x, Clear? Now I will explain you this part. We got the returns of 1000 days. And from 1000 days I got this, okay, normal distribution, I got the mean, and I got the standard deviation. But now I want to know what is the probability that I will get 3% return. What is the probability that I will get 3%, or what is the probability that I will get my return between 4 to 3%? What is the probability that I will get 3% return? Or my second question can be, what is the probability that I will get return between 4 to 3%? Then for better calculation, we use the formula of normal distribution. And that formula will give me the probability. Because see, at the end what you need? At the end you need the probability. So classifying your data, that your data belongs to particular distribution, it actually simplifies your calculation for the probability. Now suppose I will tell you one thing. Your data include all the numbers, say 4%, 3%, 2.8%, 2.6%, 2.4%, 2.3%. Some are negative, some are positive. Suppose it also include the 0%, means the price at which the market opened, means the price at which S&P 500 opened, at the same price S&P 500 closed. That can also be possible. There can be 3% minus, there can be 4.8% plus minus. But suppose suppose you want to know what is the probability that your returns will come between say 2.5%, negative 2.5% to negative 1.5%. If this is something which you want to know, okay, so how you will deal with the help of normal distribution data, because normal distribution will provide you the formula that with the help of that formula you can identify that what is the probability that my return is going to be in between these two values. Clear? Now this side it can take the value to negative infinity, and this side it can take the value to positive infinity. Means on this scale, on the values of, these are the values of return, and it can take any values from negative infinity to positive infinity. Clear? Now let us see that how we actually identify the probability. Okay, this is our normal distribution, and suppose here the mean is 3.1%. suppose this is the mean, and I want to know the probability from say 1.7% to 3.9%. okay, I want to know the probability. Write down, I want to know the probability that I will generate returns between 1.7% and 3.9%. Clear? Now one more thing, that this normal distribution belongs to continuous random variable. So if this is a continuous random variable, then we can calculate two things. One is the probability density function, and one is the cumulative distribution probability. Clear? And one more thing, that we cannot identify the probability at a single point. At every single point the probability is going to remain 0. So we need to take an interval. So this is the interval. Clear? That between these two interval I need to find out the probability. So what is actually the probability? Probability is the area under the curve. What is probability? It is the area under the curve. Okay, this yellow portion is actually your probability. This is your probability. And how you calculate this? Area under the curve. And how you will identify area under the curve? With the help of integration. You need to take the help of integration, and with the help of integration we will identify that what is the probability of the returns between 1.7% to 3.9%. Now I will tell you what is the PDF or f of x of normal distribution. This is equals to 1 by sigma root over 2 pi 1 by sigma root over 2 pi e to the power minus half x minus mu divided by sigma whole square. Clear? This is the PDF, and you need to learn it. Clear? So what is sigma? This is the standard deviation of the data. What is mu? This is the mean of the data. Clear? So from that data we are using the sigma and mu. And here we are incorporating the term x, means we are trying to find out the density at that particular point. Don't confuse yourself that density is the probability. Density, this PDF is actually giving you the height. At every particular value of x. This is giving you the height at every value of x, but height doesn't matter to you. Because at a single point the probability is 0. So what you will do? Like this you will take many heights. like this you will take many heights. Okay, suppose this point is 2.4%. So you have taken the heights for different two values and all the values in between. You have taken the heights for these two values and all the values in between. Now what you need, this portion, okay, this portion, the area, by doing the integration you will identify the area between these two lines. You will identify the area between these two lines. So this curve, okay, there is a curve and that curve got the equation and that curve got the equation. And what is the equation of that curve? This is the equation of that curve. This is the equation of that curve, and with the help of this equation you can identify the area under the curve. And that area, try to think, if this is a curve, and can you identify the area of this line? You cannot identify the area of the line, but in order to find out the area you need to make two lines so that in between there will be some area. Okay, you cannot identify the area of this line because line don't have any area, we know that. Clear? Line have only length, not breadth. So in order to find out the area we need 2 points. So this is the basic point with respect to continuous random variable, that how we find out the probability. We find out the probability with the help of area. And how we find out the area? With the help of integration. Clear? An integration of this curve. There is an equation of this curve, and that equation of the curve is given by f of x. That equation is given by f of x. Clear? So this is the equation of the curve, and in this equation we will put the value of x, sigma and mu. Clear? And then we will get the probability. Clear? Now if we want to calculate the value of the probability for this area, we can do one more thing. Okay, what we can do, if you'll remember our CDF, that is cumulative probability distribution. So what CDF always calculate? It always calculate value less than. It always calculate value less than. Means suppose this is your mean 3% and here the value on the x is 4%. Suppose if I write like this, what is the probability? What is the probability for the value x less than 4%? Less than 4%. So what it will take? It will take all the values. It will take all the values towards the left. It will take all the values towards the left. Means it will give you all the area in the curve towards the left of 4%. Clear? Now there is one more line which is 2%. I will write next statement. What is the probability for the value x less than 2%? So means for this one it will consider all the values towards the left of 2%. It will consider all the values towards the left of 2%. Now we have area, we have both the areas. We have both the areas, this area and this area. Clear? Now if I'll write the statement, what is the probability for the value of x between 2% and 4%? Between 2% and 4%. So what we can do? What we can do to find out the value? We will use this full area. Okay, we will use this full area. Clear? Means the area of less than 4%. Clear? And we will minus the area of less than 2%. Clear? So see, from the whole yellow portion, if you will remove this green portion, what are you left with? What are you left with? You are left with this portion. You are left with this portion, and this portion is the area between 2% and 4%. This portion is the area between 2% and 4%. This one is 2%, this one is 4%, this one is 3%. Clear? Hopefully you got the theme. What I would like to say, that we will find out the difference between the two cumulative probability to find out this probability. First of all, we find out the probability for less than 4%. Then we need to find out the probability for less than 2%. And by deducting 4 from 2, we can find out the gap between 4 and 2. Clear? So what is the probability for the value of x between 2% and 4% is actually the probability of 4% minus the probability of 2%. Clear? Okay, so let us see that how we actually find out the probability for the value of less than 4. Clear? Now if I am creating this curve, and this curve belong to normal distribution, so this curve will have an equation, because this curve is an fx. Okay, what is the equation of the fx? 1 by sigma root over 2 pi e to the power minus half, then x minus mu sigma whole square. This is the equation of this curve. Clear? Now suppose this is my 4%, and the mean of this curve is suppose 3%, and standard deviation of this curve is suppose 1.2%. Clear? So we need to find out the value for x less than 4%. So means what? I need to take all the values towards the left of 4%. And how we find out the area? How we actually find out the area? We find out the area with the help of integration, where lower value is minus infinity, and upper value is 4, where upper value is 4. Now what I will write in this integration? It will be 1 by sigma will be replaced by 1.2 root over 2 pi e to the power minus half. Then what is my x? X is 4 minus what is mu? 3%. Divide by what is my sigma? 1.2 square. Clear? So now if I will solve this, if I am going to solve this, I can find out the value. If I will solve this, I can find out the value. So when I am just solving this portion, okay, because here I have taken the value of x as 4, so can I say this is equivalent to my PDF? Because when I am calculating the value at a point, this will become my PDF, and after solving this, it will give me the value of 0.234, and this 0.234 is our probability density function. Clear? But in case I will remove this 4 by x, and if I'll solve this for the integration, taking here it is dx, now that will give me the value for this area, so I don't want to enter into the integration, but after solving this we will get the value of 0.7976. After solving this we will get the value of 0.7976, means it is showing us that 79.76% of the data falls towards the left of 4%. Suppose I would have been asking you, what is the area towards the right, or what is the probability that the return will be greater than 4? If I will be writing the question like this, what is the probability that the return will be greater than 4? So try to understand what this 79.76% tells you, that the probability of the return less than 4. So if I want to know the probability of the return greater than 4, simply I can do 1 minus 7.7976, because see, the whole area is 1. The whole area is 1, but out of this whole area, the yellow portion is 0.79. The yellow portion is 0.79. So what is the value towards the right? So towards the right, it is going to be 0.21. So probability of the return less than 4%, 0.79. Probability of the return greater than 4%, 0.21. Clear? Now if I'll change little bit, keeping the same question where mu is 3%, sigma is 1.2. I want to know the probability of the returns between 2% and 4%. Write down the question. Probability of return between 2% and 4%. Clear? So simply again you need to take the integration first of all, starting from negative infinity to 4, negative infinity to 4, and you need to take another integration starting from negative infinity to 2, and they both will give you the value. And that value is our cumulative, cumulative value, cumulative probability. So I will give you the value. You don't have to solve for the integration, and even in the examination they won't ask you to solve via integration, because later I am going to tell you some simplified way to solve this kind of question without the help of these integration. But first of all, we need to build our strong basic, that how actually we are getting these values. So for the 4% we have already calculated, it is 0.7976. So here I have written the values for towards probability for x less than 4%, probability for x less than 4%, and this one is probability for x less than 2%. Clear? So let me draw the graph to make you understand. This one is 4%, this one is 2%. Clear? But the probability, that is 0.7976, is for this area, 0.7976, and 2023 is for this area, 0.2023, and I need the value for this area. So simply, if this is the area 7976 and I will remove this area, I am left with this portion. So the probability for x less than 4% but x greater than 2% is equals to 0.7976 minus 0.2023. Clear? So the answer is 0.5953, or you can say 59.53% chances that my returns are going to be between 2% and 4%. Clear? Okay, so let us see that how we can simplify and find out these probabilities without doing any of the integration. So simplification of normal distribution, we are going to use the same thing. Clear? Now what additional thing we are adding is a z value. Okay, now in order to simplify, we need to simplify something, so we are creating a new z value. Now what is this z value actually is? First of all, I will write the formula and then we will do something. Okay, this is the formula to find out the z value. Now what this z value actually is, see, what is this x? This x means 4%. What is our mu? Was 3%. What is my standard deviation? It was 1.2%. Clear? So this will give me the z value. Let us calculate. That is z is equals to 1 by 1.2, 1 by 1.2. So z is equals to 0.833. Clear? Are you getting the point? This is the value of the z. Now if you will look at a z table, okay, there is a z table, and if you look at the z table, now I will tell you how to look at the z table. Now I'm not explaining anything, just telling you that how we are actually getting the values. You can look at the z table, it will be given in front of you in the form of different books, but I'll be putting, see, here are some values and here are some values of the z, and in between there are probabilities. In between there are probability. These are the values of z and these as well are the values of z. Clear? So if you look at the z, they both starts from the 0. They both start from the 0. If the z value is 0, if the z value is 0, the probability is 0.50. If the z value is 0, probability is 0.50. Clear? Now let us move ahead. There is, if you'll go down, there is 0.8. Clear? And if you'll go towards the right, it will be 0.01, 0.03. Clear? Now there is one value here, 0.7967. Now how you are going to read this? See, for the first value after the decimal, you will take this part, and for the second value after the decimal, you will take this line. So what was the value of the z? 0.83. 0.83. So this is the line of 0.8 and this is the line of 0.03, means this part. So this is your actual probability. This is your actual probability. Hopefully you are understanding, and the more we'll do, you will understand how to read the z table. Now I'm not explaining you the reason, not yet. Okay, later I will explain you the reason, but just for the time being, because we are in the flow of calculation, so I am continuing that flow so that you won't get distracted by the another concepts. Clear? Okay, what was my another value? My another value was x equals to 3. So it will be, sorry, x equals to 2. So 2 minus, what is the value of mu? 3. And what is sigma? 1.2. So it is also giving minus 0.833. Minus 0.833. See, till now we have calculated the probability for z. Probability for z less than 0.833. Clear? Now we need to calculate the probability for z less than negative 0.833. Hopefully you are understanding. This belongs to this part. Clear? But when it comes to negative number, my z table, they do not have any of the negative numbers in the table. You will find only positive numbers. So anyhow you need to convert this portion into positive. You need to convert this portion into positive. So let us see that how we are going to do that. Okay, for this part, first of all, I need to make you visualize the graph. This is our graph where we have the value for z. Okay, this is my, suppose this is my z. This time it's not x. So here I got the value 0. In between there is a value 0. Towards the right there is 1, then 2, and then 3. And towards the left there is minus 1, minus 2, and minus 3. Okay, this is how my z table is actually presenting in front of us. Clear? Now if you look at the table, it is showing you only positive value starting from 0 to 3. It is showing only the positive value to you starting from 0 to 3. Clear? We do not have any probability for the negative portion. Now you will ask me why. You will ask me why there are no values available for the negative side. Try to think, if I am asking you that if my z means z is 1, if I am asking if my z is 1, what actually I am trying to calculate? I am trying to calculate all the area in this curve towards the left. What I am calculating? All the area towards the left in this curve. Clear? Now if we look at the Z table, if we will look at the Z table for the 1, okay, it is giving us 0.8413. okay, this is the Z value, sorry, this is the probability when the Z value is equals to 1. This is the probability when the Z value is equals to 1. Now if I'll ask you, what is the probability towards the right of 1? What is the probability towards the right of 1? Simply you can find out this by 1 minus 0.8413, because the whole yellow section is 0.8413. so what this blue section is about? 1 minus. Okay, so let us find out the value. So this value is equals to 0.1587. Clear? So you can write down two things. One thing is that probability for Z less than 1 is 0.8413. Probability for Z greater than 1 is 0.1587. Clear? Now hopefully you got the idea that the tables which we have is only talking about the probability towards the left. Okay, this is the concept of the table, that it takes only the value towards the left. Takes only the value towards the left. Clear? So if I want to know the probability towards the right, I need to take plus minus help. Clear? So this is how I am getting the probability for both the side. Now if I want to know the probability for minus 1, if I want to know the probability of Z less than minus 1, write down this part. Probability of Z less than minus 1. Clear? This is something which I want to know. Can I say this is equals to probability of Z? This is equals to probability of Z greater than 1. This is equals to probability of Z greater than 1. Try to satisfy yourself. See, my normal distribution is symmetrical. Okay, again I am making the graph. Here I have plus 1, here I have minus 1. Clear? Now if my graph is symmetrical, then this area and this area is going to remain the same. This area and this area is going to remain the same. No one can say they both are different. So if the probability of this side is 0.1587, then also the probability this side is also 0.1587. Please satisfy yourself, because if the area is same, then probability is definitely the same. Okay, coming back to this portion again. First of all, if I'm saying that they both are equal, okay, if they both are equal, so how I have calculated this portion? This is equals to 1 minus probability of Z less than 1. This is equals to 1 minus probability of Z less than 1. So from this portion, if I want to know the probability of Z less than minus 1 is equals to probability of Z greater than 1 is equals to 1 minus probability of Z less than 1. 1 minus probability of Z less than 1. So this can be written like this as well. Hopefully you are understanding the concept. It will take some time. When you will practice this 2 times, 3 times, 4 times, you will be comfortable. But in the beginning, in the starting phase, you need to spend more and more time while understanding the concepts. Okay, so let us do some more practical questions so that we'll become comfortable with this. Suppose the mean of the data is 7 and let us take the standard deviation of the data is 2. We need to find out, okay, this is in terms of percentage. Find out the probability for x greater than 2. Find out the probability for x greater than 2. Find out the probability for x less than minus 2. Find out the probability for x greater than 4. find out the probability for x less than 3 but greater than -1. Find out the probability. Okay, these 4 probabilities. Now if we will be able to find out, then definitely, trust me, we will become very confident with our preparation. Clear? So simply we have to convert x into z. First of all, we need to convert the values of x into z. So how we will do it? Let us see that. Let me draw a normal curve. This is the value of x. This is the value of z. For x, here we have 7%, and for z we have 0 in the middle. Clear? Now standard deviation is given as 2%. Now let us calculate the value for z when x equals to 2. So x minus mean divided by standard deviation. So it will be minus 5 by 2, that is 0.25, negative 0.25. So means when my x will be equals to 2, my z will be equals to minus 0.25. Clear? Hopefully you are getting the point. When x equals to 2, z is equals to minus 0.25. Clear? Okay, better change this one and let us change it to 9. Clear? Okay, so when my x is 9%, what will be the value of z? So z is equals to 9 minus 7 by 2, means 1. Clear? So when x is 9, my z is going to be 1. Now when x is minus 1, means here I am talking where x is minus 1, what is the value of the z? Z is equals to minus 1 minus 7 by 2. It is going to be minus 4. In this case, the value is going to be minus 4. Clear? Now when x equals to 3, so now your value is somewhere going to come between minus 4 and minus 0.25. So when x equals to 3, minus 7 divided by 2, so it is going to be minus 2. Clear? Minus 2. And I want to change one value, that from minus 1 I want to change it to minus 2. Okay, so better we will change the value here as well, otherwise our calculation is going to be very complicated. So rather than using here minus 1, let us use minus 2. Clear? Or to be more precise, we can make it better number. Let us make it 0, because that will be new to you. Okay, now what will be the value of the z in that case? So it will be 0 minus 7 by 2, so it will be minus 3.5. So let us change the value here, minus 3.5. But we know one thing, that my z table is only till 3.09, means you won't find any values for negative 0.35, because the probability for the values less than minus 3.5 is equal to 0, means the probability is negligible. Clear? But still we will do it so that we can understand the concept. So let us see first one, that is probability for x greater than 2. Now what is my z value? Minus 1.25. Now here I am just considering the z value. Here I have 0. So this time I got the value as minus 0.25. Clear? And what is the requirement? The requirement is the probability of z greater than, what they are asking, probability for z greater than minus 0.25, means the question is asking the probability towards the right. Clear? So what I will do, I will first of all calculate the probability for this side and then I will minus for that side. Clear? But there is one more problem. What is the problem? That in the Z table you do not have any values which are negative. So remember our previous session what we did. So better we will create here one more line which is about 0.25. Now try to think. First of all think that the probability of Z less than 0.25 is this black area. Try to think and let's move ahead. The probability for Z less than 0.25, this black area. Clear? Now if I will do 1 minus probability of Z less than 0.125, if I will do 1 minus probability, what I will get? This portion is equals to this area. Clear? Now try to think one more thing. Probability for Z less than minus 1.25 is equals to 1 minus probability of Z less than 1.25. See what I have written. This portion is equal to this portion. This portion is equals to this portion. And this portion is equal to this portion. And they both are going to remain the same because they both are symmetric in nature. Hopefully you are getting the point. Okay, so let us write numerically. This value is equals to 0.5987. So this value will be equals to 1 minus 0.5987 is 0.4013. Clear? Now this value, the right side which I am writing is 0.413. Sorry, 0.4013. And now this side, look at it, is the probability of Z less than. So means this one is 0.4013. Clear? Now what probability I want? What is the probability which I want? I want the probability towards the right of this line. I want the probability towards the right of this line. Clear? So can you say the whole graph is 1, and from that graph if you will remove this yellow portion you will get this line, means you will get the whole area towards the right. So probability of Z greater than minus 0.25 is equals to 1 minus 0.4013, which is equals to 0.5987. Hopefully I have tried to make it longer so that you will understand the concept. Okay, otherwise I could have tell you that they both are equal. Otherwise I would have told you that they both are equal. Clear? But just to explain you the process that what I am going through is this. Clear? So you can do one thing. What I can do, if the probability of Z, if they are asking me greater than 1, okay, greater than minus 1, that will be equals to probability of Z less than 1. Clear? So means with the sign of greater than negative, you can change the sign of plus minus as well. Clear? But if you can't understand that, this is the process which you have to follow to find out the probability. Similarly, these three will be our task. And we have to solve this. Clear? So you can do that as a homework. Okay, just by practicing. Now, how we got this Z? How we got this Z, and what actually this is, and what actually this is. See, we have a normal distribution. And in calculating all the values, we are facing lots of difficulties. Clear? So what we try to do, we try to create a new normal distribution, that is standard normal distribution. Clear? here we are calculating the probability for x. Here we are calculating the probability for the x, where x follows normal distribution, where mean is the mu and variance is the sigma square, where mean is the mu and variance is sigma square. But this time when I am creating the standard normal distribution, my x follows normal, where mean is 0 and variance is 1, or we can say standard deviation is 1, where mean is 0 and standard deviation is 1. So means what I am trying to do, see the word, I am trying to standardize my normal distribution. Now see what actually we are doing. Z is equals to x minus mu by sigma. Means for every value of one standard deviation, what is the z value? For every value of one standard deviation, what is the z value? Now if my mean is 7, and I am calculating the value at 7, my z is going to be 0. See again, if you'll remember, previously also I have shown you that if my mean is 7%, this is x, and if I am creating a z, so my 7% will be equals to 0 of z. My 7% will be equals to 0 of z. Let me show you where I have told you this portion. Remember, I have created the 7 here and just 0 at the bottom. Clear? This means that wherever I am getting 7, that is the mean of the normal distribution, will actually the point is 0 as the standard normal distribution. Means I am trying to standardize my normal distribution so that it will be easy for the purpose of calculation. And when I am dividing it by standard deviation, to ensure that if suppose my standard deviation is 2, means for 2 standard deviation I have 1 minus mu, x minus mu. So what my standard deviation is 1, means for every one standard deviation, what I have to do? I have to divide it by 2. For 2 standard deviation, right? So what is the value for 1 standard deviation? So I need to standardize it. Clear? So I am getting the z value. Now one more thing, let me take you back. What I am trying to standardize, which portion? Let me show you. Yes. Hopefully you can remember this portion. This is the portion which I am trying to standardize, means removing the x, removing the mu, removing the sigma and putting z here. Simply I am putting the value of z here. Clear? So can you see that I have simplified my equation, that is 1 by sigma root over 2 pi e to the power minus half z square. Okay, so now my equation simplified. Clear? Now how we created the table, how we actually created the table. So we have taken the values of the z, integrated it. Suppose I have taken the value from negative infinity to say 1.25. Clear? So if you look at the table, here you will find 1.2, here you will find 0.05, and in this portion I am putting this value. So simply I am calculating, I am doing the integration for each of the values, and I have created this table. So now I have to do integration only once, and I have created the table. So I can refer the table, and without doing the integration I can find out the probability. But what if this table would have not been there? I have to solve for each and every integration. So in order to simplify the process of integration, we have done our integration only once, and I have entered all the values of z. In our table, so that I do not have to go again and again for the integration. Simply what I will do, I will transform my normal distribution into standard normal distribution, and from the standard normal distribution I will calculate the z. I will go to the table, I will find out the probability, task is over. Hopefully now you are understanding. They both are same. Normal distribution and standard normal distribution, they both are same, but just the difference is of standardization. I am standardizing my mean and the sigma, where in the standard normal distribution mean is equals to 0, sigma is equals to 1. Only this is the basic concept of normal distribution and standard normal distribution. Hopefully you are comfortable with the whole process, the way we have went through this process of understanding the normal distribution. Okay, so we will add some of the numericals. So we'll cover numericals in another lecture. That numericals will be completely focused on normal distribution and standard distribution Clear? Just few of the things at the end. If x follows normal distribution, so here the parameters will be this, and if x follows standard normal distribution, so we know that mean is 0 and standard deviation is 1. Clear? Thank you.